All right, before we proceed with a quick recap of the notes or of the lecture content, probably I would like to ask all of you if you have any questions about the previous chapter. Introduction to high voltage, chapter 1, chapter 2, breakdown in dielectric, and chapter 3, generation of high voltage generation. Do you have any questions on these 3 chapters? Ada tak? Do you have any questions? Jospin, do you have questions, Jospin?
Sepatutnya tak ada, doktor.
Tak ada. Nur Azrini. Azrini,
Ya, saya doktor.
do you have any questions?
Setakat ni
Setakat ni semua tak ada. Ibrahim Arif.
Ya, doktor.
Ibrahim, do you have any questions?
No, doktor.
So far, so good.
So far, so good.
I'm not sure how you did, all of you did in your quiz. Hopefully everything is okay and you managed to answer it very well. Okay, for today I planned my plan while waiting for questions from all of you. Probably in the meantime, I'll just go through the lecture notes, a quick recap, a quick one, okay? A quick recap for the previous notes, especially on the chapter 2 and 3. For chapter 1, I didn't. Okay, jap. For chapter 1, I need to see introduction. Okay, and chapter 1 as well. Okay, let me just open this one. Then now a window. Okay, I try to target maybe 5 to 10 minutes for each chapter. Can you see now? Boleh kan? The slide introduction to high voltage. Okay, for the introduction of the high voltage, what most important for you to know is for the introduction to high voltage engineering. Okay, first we need to know about the element of the high voltage. What are the required element in for the high voltage? I mean, the composition, whether it's made of insulation, clearance, and then all generation, transformer, all this you need to familiar with. Okay, no need to worry on the history of high voltage engineering, but you can read obvious for your own knowledge. And the problem with the high voltage engineering, okay, problem related to the high voltage engineering. Okay, what are the typical issues with the high voltage engineering? And then okay, let me just, oh sorry, yeah, battery. Okay, okay, ni component of high voltage engineering, normal flow and abnormal flow. Okay, what is considered as normal flow? What is considered as abnormal flow? Abnormal flow under faulty conditions, under lightning strike, under disturbance to the power frequency, and then Ferranti effect, the switching and the faulty phenomena. So abnormal flow means that the distortion to the high voltage transmission line. Okay, for this kind of what people do with the high voltage. Okay, why people interested to perform the high voltage AC, DC, and impulse. Okay. Of course, for AC, it is obvious that we need to transmit over the transmission distribution line. How about for DC and impulse? What we do to this voltage? Okay. So primarily for the impulse, high voltage impulse. So uh, we the researcher required the high voltage generator or high voltage impulse generator is for the laboratory test. Okay, why do we need the laboratory test? Because we want to test the insulation's strength. We want to test for the equipment device in the protection device in the high voltage transformers, and we want to test many other equipment in the high voltage. That's why we need the high voltage generator, high voltage impulse generator. Okay, if not, and also we need the high voltage impulse generator for us to simulate the nature phenomena. For example, lightning. Okay, and the other one, of course, the switching activity, so that we can test the device in the high voltage to be at the maximum at the good working conditions. Okay, so without the test, there is no necessary for high voltage impulse or DC to be generated. Okay, there's no other function except for testing of the equipment, setting of the device, protection device in high voltage. Okay, okay, and then you can quickly have a look at this main international body, for example, IEEE, IEC, SIGRE, ISH, and many more. Okay, that's about it for the chapter 1, introduction. So importance of proper high voltage system in place. Okay, so for this one, you don't need to read text, but you can refer, or maybe from here, from your understanding, you can establish any possible reason for the importance of a proper high voltage system in place. What are the example? Okay, actually the example is the point that is written in the notes. It's available in the notes from the beginning. It is not like the beginning of the lecture. For example, importance of proper high voltage system. One, to ensure a reliability of high voltage transmission, power distribution, and etc. And then what other thing that you could think? Okay, this is something that you can actually think by yourself. You don't need to refer to the notes anyway. But there is some part of the notes that explain the importance of proper high voltage, but you can actually produce by yourself by thinking. For example, we want to ensure safety of human equipment and device, and then to improve the reliability, and then uh, to avoid catastrophic failure, uh, to continuously supply electricity to the consumer, and many more. That is the reason why we need to avoid the failure or disaster like this one. For example, a transformer explode, and then we want to avoid the explosions. We want to avoid the failure, for example, failure of the insulation due to flashover, and we want to entertain so that we can handle the faulty conditions. Okay, the faulty like from the lightning and switching, so that they are well managed in terms of the protection. There are many that you can develop. Okay, that is for the introduction. Any questions for this part? Any questions? Okay, tak ada questions. I'll just stop here, and then I will continue with chapter 2. Chapter 2. Okay, this one. I don't know, somehow my screen is there is some distortion in this PDF file. I'm not sure whether you can see it or not. uh, in like this one, it's just a page title without other uh, without the background color at the back. Okay, that's fine. Okay, then after we understand about overview about the high voltage and situations and high voltage and equipment elements, and then now we come to the one of the primary elements in the high voltage system, in which we talk about the dielectric. Okay, dielectric, why it is important? Because we are dealing with high voltage. Of course, the dielectric is required to provide a good insulations to the high voltage, to the energized structure. This is primary as a protection to the high voltage device and component. So this is a kind of mandatory. And before we can actually develop a high voltage, we need to first to know and to understand the dielectric or insulation characteristic, yeah, dielectric properties to ensure that the high voltage engineering that we generate is within the safe level, right? And within the control of this insulation system. Okay, there are three main categories of the dielectric material. A quick recap: we have a gas, we have solid, and we have gas, liquid, and solid. All of these dielectric materials have their own function for certain application and device. It is being used depend on application. Okay, what is dielectric? You can read obviously from the notes, but in simplest mean, it is like an insulator. It is basically the insulator for the high voltage uh, power equipment, right? Okay, the definition you can read here. Okay, you can read in the text. So basically, okay, why it is essential to provide the protection to the power system equipment, to provide a mechanical support, for example, mechanical support in case the insulator or dielectric material being used as a suspension insulator, in which we hang over the transmission tower, and then to provide uh, very high resistance to the current flow. Okay, purpose of dielectric, saya tak repeat. Okay, you need to enhance the importance of dielectric material. Okay, we use dielectric material. Okay, like mechanical strength. These are the characteristic or the consideration that we need to take into account to develop the insulation material. One, okay, we need to consider the mechanical strength that insulator need to support, and then processability. Is no point we propose a very good insulator, very good dielectric materials, but it is not processable. Means that it's not practically to be produced or manufactured. Cost and thermal conductivity, of course, to allow for the heat dissipation from the high voltage equipment, for example, transformer. So you can read problem with dielectric. Okay, the ultimate problem of the dielectric is that we are facing with a serious problem of a breakdown. Okay, these dielectric materials under good working condition is okay. They exhibit as the insulator and they prevent the current flow, but uh, under abnormal condition, this dielectric material can actually break down. Means that it malfunction. It will not operate as the insulator. Okay, once it's breakdown, there'll be a conduction. Okay, there'll be conduction, and then the insulator will become a conductor. Okay, we studied in great detail the breakdown phenomena in the gas, dielectric, gas, liquid, and solid. So fundamentally for all of these three material, the process start with the ionization. Okay, most of them is actually from the ionization. What is ionization? Okay, what is actually the ionization? So hopefully you should be able to explain what is the ionization process in brief. Okay, the process of formation. Uh, okay, the formation of negative electron from the molecule, how they converting an atom molecule into an ion, okay, by adding or removal of the charged particle. Okay, this is ionization. And then you may briefly explain of the ionization process, how it happened at molecular base and how it could trigger for the failure. Okay, ionization process. Okay, this is the most important element for the breakdown to occur in the gas, solid, and dielectric. In fact, for solid and dielectric, this is also contributed due to the intrinsic ionization process. Okay. Okay, and then we need to know these ionization progressions. Okay, first how is the ionization process initiate, and then the second phase, how this ionization progress, means that how it become become progress from time to time. It can progress by first we have the collisions, we have the photoionization process, and we have the surface of electrode. This is how the ionization progress, means that it start with a small one, just a electron escape from the molecule, or maybe collisions by the other electron over the other molecule, and hence it gain the electron energy certain to escape away from the nucleus, and then this collision process will collide with others, and it will become like a progression. uh, it will become like a progression arithmetic, progression by collisions. Okay, so try to understand, try to have a gist. Okay, gist, what is ionization by collisions, what is photoionization, what is surface of electron. Try to have a gist. I don't want to repeat this, of course. So at least you need to know what is ionization by collision, how this process happen. At least you should be able to explain. Okay, what is step ionization? What is photoionization? What is ionization in the surface of electrode? Okay, these are some method in which the ionization progress. Ionization within the dielectric material progress to become to lead to the total breakdown. Okay, here next for the gas, how they progress, and then we learned three theory or mechanism that help to explain the breakdown phenomena in the gas. Okay, we have we have this one. Okay, first is Townsend phenomena, and then the second one is streamers, and then the third one is Paschen law. Okay, please have a look at them, all of these three theory, and try to differentiate between these three. What are the difference between Townsend and for example, Townsend and the streamers principle? Okay, try to identify what are the difference, what are the common, how they develop, how they perform the experiment. At least we need to know some basic fundamental of this theory. Okay, the experiment, how Townsend conduct the experiment, and the output waveforms, stage 1, 2, 3, and 4. At least just a quick summary on this. Okay, Townsend method. Okay, some important keywords that I would like to highlight here. Maybe Townsend region 1, what is that? What is that? You can actually know that is photo ionization process, in which, okay, then you can quickly recall this is from the UV light, from the UV light that help to trigger for the ionization. That is for region 1. And region 2, saturated photo ionization process. We have the saturated region. And then ionization by collisions in region 3. How that's one happen? Maybe try to summarize by yourself for each region with 1 or 2 sentences. That's it. What is most important in each region? Try to highlight, try to address 1 or 2 important keyword or sentence for each of these 4 stages. Okay. The Townsend, we're done with the Townsend. Okay. For this calculation, how to calculate the primary and secondary coefficient. How to calculate by using this formula. Okay, plasma, and then these are very simple and quite straightforward. I do believe that you should be able to do it very well. Okay, and then problem with the Townsend principle. Okay, problem with Townsend principle. If you can see carefully here, this is actually the difference between Townsend and the Townsend and the streamers. Townsend cannot explain on the transient condition much faster. Okay, very short periods of time. It's transient phenomena in which the streamers explain try to overcome the problem to try to help to explain the phenomena under transient conditions. Okay, what is streamers? We have these 3 main categories, 3 main process. First is that a formation of an avalanche by electron. Okay, this is the primary process. And then the second one is that a local enhancement that distort the electric field. And then we have the secondary avalanche ataupun progression that lead to the total failure of the streamers. Okay, the streamers help to explain the Townsend under transient conditions. Okay, you can read these 3 process in detail. It's available there. And then Townsend and versus streamers principle. Okay, so we understand that streamer principle based on the formation of auxiliary avalanche in the gap. Okay, and this one Townsend principle is based on successive generation of avalanche initiated from the cathode. These are the difference. The difference between Townsend and the streamers. And you can read here. And then we have here the streamers principle, how to calculate based on some mathematical formulation. And then this is also quite straightforward. It's just a mathematics. We have the formula and we have the values, and you can calculate. Okay. Okay, what is Paschen law? Okay, Paschen law. Okay, what Paschen law? Okay, what Paschen law is all about? Okay, so we have a Paschen law. The product. Okay, depending. Okay, Paschen law describe how Paschen law describe breakdown phenomena. It depends. It classify that the breakdown is depend upon the pressure and the temperature. Okay, patient try to involve the pressure and temperature. Okay, this is patient curve, and then you can read what is happening at the before and at the line and after the line from the explanation. And we have these formulations in which you can actually use to calculate some values. This one is also quite straightforward. It's just mathematics again. We have the formula and we have the values given in the tutorial, and then should be able to calculate. It just a matter, maybe we try to reshuffling here. In this case, for your final exam, maybe we change the value, we change the parameter required. Okay. So this is patient law. How we calculate use the formula to calculate the value, say at the given pressure, and then we need to comment what will happen. What we need to draw the attentions or to draw a conclusions what will happen if the pressure is increased or decreased by a certain values, and then we'll get the increment and decrement values. Okay, this is the plot. Based on this one, we can suggest that how the pressure and of the gas influence the breakdown values. Okay. Okay, that's about it for the gas. Let's stop here. Do you have any questions on the gas before I come to this solid? Before I come to okay, so for the gas, make sure you should be able to. Can you see the slide here? A breakdown in liquid.
Yes, doctor.
Alright, good. Thank you. Okay, breakdown in the gas. Just try to this one is in the liquid. Okay. So you need to be able to differentiate. Okay, what are the characteristic of the liquid as compared to other, for example, gas and solid. Make sure you know. Make sure we know how to, for example, what's the difference in terms of the characteristic. Okay, for example, the liquid occupied the space in which the solid dielectric is not occupied the space. That is one example. And then the second one, maybe the liquid has the has the higher dielectric strength as compared to the gas, for example. And then you need to be able to extract and try to find some more in comparing to the gas or liquid. Okay, we use it in transformers. I don't want to repeat. Problem with the liquid dielectric again. Problem with the liquid dielectric again is about the failure, the breakdown of the material. Okay, how the breakdown could actually happen in the liquid. Okay, so we have the process in the liquid itself, means that the process within the liquid, and then we have the movement of the oil and particulates contaminant. Okay, movement due to the convection of the oil, transformer oil, liquid is moved from top to the bottom and then bottom to the top and touch the metal surface that lead to the failure or lead to the discharge activity. Cavity formation. Okay, cavity formation, the formation of air bubbles or void or water bubble within the liquid dielectric. This is due to due to the process within the within the transformer. And then also we have the chemical reaction. Okay, we have these four main process that lead to the trigger to the failure of liquid dielectric. Okay, you can see the conduction process. You can read the text, and the conduction conduction due to the movement of oil. Okay, conduction, we have five types category for this conduction of the contaminant. First, we have the dielectric pyrolysis, forced and natural convection, thermal convection, electroconvection, and static electrifications. Okay, we have five of these that trigger for the movement of particulate contaminant within the transformer oil. That is how they move. Okay, you can read this one. Static conduction due to, okay. Okay, next we look at the conduction due to cavity. Okay, cavity formation, and last but not least, a chemical reaction. Okay, so sorry, where is it? Okay, we have four of these conduction process that lead to the failure. Process conduction as what we can see in the liquid, the conduction process, and then cavity, movement of oil and particulates. Okay, how the particulates or contaminant move within the material, we have five method, 1, 2, 3, 4, 5. And then next is the conduction process by due to cavity, different by air bubbles or water bubbles within the gas, within the solid. And then not to deny, we will have the chemical reaction. For example, we have the deposition of the metal tank material that can react with the void, with the liquid, etc. That will lead to the failure. And then please, you need to know these five type of the movement of the oil, how they move within the material. Dielectrophoresis, force and natural convection, thermal electroconvection, and then static electrification. Okay, that's about liquid, and last, second last, we go to the solid. About solid, okay, for solid, okay. Okay, solid. Again, it is expected for a student to differentiate what is solid, what is liquid, and what is gas, and how they difference between one to another. What are advantage and disadvantage of this type of state of dielectric. Okay, solid dielectric. Okay, we know the most common one is should be reflect to the cable. Okay, we use a solid dielectric material. For the cable, we use solid dielectric material for the insulator. And also, not to deny, for the transformer, we have the paper insulated. Okay, these are the example. Problem with solid dielectric also is due to the breakdown phenomena. Okay, the breakdown could happen differently as compared to the gas. First, the initiation of the ionization. Of course, this is the primary factor that trigger to the failure of the any dielectric material. But the formation within the solid dielectric might slightly different because it's not replenishable. Once the solid dielectric breakdown, the solid need to be replaced. It cannot be replenished. It cannot be replenished automatically like a gas. That is the draw part. Once we have the breakdown in the solid, the material need to be replaced with a new one. Okay, we have several mechanisms that trigger to uh, the failure of the solid dielectric. First, we have the intrinsic breakdown, in which we have uh, the ionization process within the material that lead to the breakdown. We have electromechanical breakdown, the breakdown in which due to the force of electric field that compress the dielectric material until it causes a breakdown. And then we have thermal breakdown. For example, we have transformer, okay, due to thermal, due to the function of the power transformer, and then it'll become it continuously generate the joule heating, in which this could also trigger for the breakdown. Okay, intrinsic breakdown occurred at a very fast period of time, and with going down the list here, the breakdown value start to take for some time. Okay, breakdown due to treeing effect. Okay, for the treeing to happen, it take about months of years. All right, and then for breakdown due to tracking and erosion as well, this one is this one is related with time. So it will not happen instantaneously. The failure will not happen instantaneously. It will start degrade, or it will start degrade or degrade the material until it lead to the total failure. Okay, we plot at the breakdown field and the duration of the process. If you can see here, the treeing chemical and tracking and erosion take years, okay, in which the avalanche is a very fast process that happen in a microsecond, and this one is in number of months or years. Okay, intrinsic breakdown in summary is happen due to the ionization, due to the impurity. Okay, so we have the intrinsic internal properties of the material, in which that trigger to the breakdown. Okay, we have to describe the intrinsic breakdown. We have two model, in which first is the electronic breakdown model, and the second one is avalanche or streamer. So this one is the streamer, this one is the Townsend. The first one is Townsend, described by Townsend. The second one is described by streamers. So both process also occurred in the solid, but it happened internally. We may not see the effect on the surface, and then it happened internally. And then can read how streamers happen, how the breakdown at the molecular level, and then electromechanical by the force of the electric field. This one introduce the compression, so that the electric field so that solid dielectric material can have displacement in term of distortion, in term of size and shapes, that may lead to the total failure. And then okay, for these formulations, hopefully you all should be able to understand and use the formula. Okay, we have this one, Stark and Gatton analysis. Okay, we have the thickness, final thickness, and the reduced thickness, etc. So you plug in the values, and then that will give you a value that is required. For example, in this case, find the applied voltage. Okay, and the other one is the highest electric field strength. Okay. All right, so for thermal, next is thermal breakdown. Thermal breakdown is important for insulator to dissipate heat. For example, the power transformer, we need to maintain the liquid insulation within the certain temperature level. Okay. Okay, thermal breakdown could also happen in the cable. Okay, because the constant current conduction within the conductor, that will cause the joule heating, and that may cause a problem to the cable. Okay, dissipation factor. Okay, dissipation factor. Okay, this is the formula. Okay, we know this expression, and we can actually calculate the values to determine to determine the dissipation factor angle. Okay, the dissipation factor angle and the total heat absorbed or heat loss to the environment, heat loss to the uh, silicon rubber. Okay, and then by simple calculations, we plug in the values, will give you the answer. Okay, for the treeing phenomena. Okay, for the treeing phenomena. Okay, this happened after a certain period of time, after a prolonged operations. Okay, that's not happen instantaneously. And so with time, this one will degraded, and then hence that will cause a failure of the insulator. And these are the example. It's become like a tree, a root of a tree. That's why we call it treeing phenomena. And this is how we describe the stage of the tree growth. Okay, it's still okay. It's not really important for you to know, but it's good for you to at least read once, although it is not important. Okay, we have parameter involved to the tree phenomena. We have the material properties, morphology, and chemistry. We need to consider the electric field strength. We need to know the applied voltage and waveforms type, and then temperature, the joule heating, and the current from the current. Okay, these are four important parameters that will determine how the tree grows under the influence of these four stresses. Alright, water tree growth. Okay, water tree is due to the void, okay, or water trap within the material. Okay, and similarly, that's could happen with time. The difference okay, these are the electric tree growth. From the small one, you start to propagate. Okay, with time, it will start propagate at the advanced level, and then some more bigger and bigger until it lead to the failure or total breakdown. And electrical tracking is the degradation on the surface of insulator due to the arcing phenomena. We have the discharge, and then the discharge consume the surface of insulator. Means that the discharge is at a very short period of time, but the magnitude of current is quite high, and the heat generated from the discharge will somehow cause a burn to the surface of insulator, as what we can see here. So once we have the tracking, it start to make a normal path as for the current flow, and hence that will trigger for the corona discharge or dry band arcing. Okay, dry band arcing here with a very intense heat that will burn the insulator, and then at the end of the day, that will lead to the failure of the insulator. Okay, and then you don't need to worry about this one. You can read by yourself for additional knowledge. Okay, the tracking inclined plane experiment. No need, but you can always read. Obviously, we stop at this point. Okay, that's about the. Okay, that's about it for the insulations, for the dielectric, for the breakdown phenomena in the gas, liquid, and solid dielectric. Do you have any questions up till this point? Tak ada And last quick one is for the high voltage generation. Okay. Okay, after we know a little bit about the high voltage, what is all about the high voltage, and then we come to the insulation, how to provide the insulation to this high voltage equipment. Once we generate, we need the protection, how to protect the equipment from the over voltage, how to provide a good insulation to the high voltage. And then we studied the mechanism that lead to the failure of the insulator, failure of the dielectric, that is termed as dielectric breakdown. Okay, so why we need to know this? Because we want to avoid that to happen in practice. We want to avoid the dielectric breakdown to happen in practice, and that's why we need to study and fully understand the phenomena related to the breakdown of the dielectric material. And finally, for my section, and then now after we fully understand about the breakdown phenomena for the insulation, for the dielectric material, we go and review on the how to generate the high voltage. Okay, this is where we look at the high voltage generation for the AC, for the DC, and for the impulse. We are focusing on these three main high voltage generation categories because that is the what been used, commonly used in practice. Okay. Okay, for AC is simple and straightforward. It's just a normal insulator, normal transformers. And then for this one, first, in order to generate the high voltage, of course, we would require a certain device that able to step up the voltage level. That is known as the transformers. Okay, so in this section, the role of transformers is very, very important to generate the high voltage source. Okay. Okay, there are two main categories of the transformers. One is the testing transformers, and the other one is power transformers. Okay, what are the difference between these two transformers? Okay, what are the difference between a testing transformer and the power transformers? You need to identify those based on your reading here. For example, a lower kVA rating for the testing transformer is much smaller compared to the power transformer with the same power rating, flux density, and then we have the compact design. And then okay, you should be able to identify the differences, the advantage, disadvantage of power transformers and testing transformers. Okay, for the testing transformers, we have two types, two category. One is tank type, okay, this one, and the other one is insulated enclosure type. We have two type of transformer that been used in practice in the laboratory. So, but for the power transformer, we don't use it in the laboratory. We just use it in practice. So we need to deal with the tank or insulated enclosure type of the transformer. Alright, we have this one. So you need to maybe know about uh sorry, I got a sore throat. Okay, maybe you need to understand the construction design of these two transformer and able to differentiate, or maybe able to take note on the advantage and disadvantage of these two transformer. What are the advantage of this one and what are disadvantage of this one? Okay, you can have a look and read to know the advantage or the characteristic of the insulated enclosure types and the tank types. And then we move to we have the straight transformer. There are three main category. For the HVAC, we have a single straight transformer, we have the cascaded, and we have the resonant. Okay. Okay, single straight transformer is straightforward, and then we go straight away and we experience a problem known as resonant. Okay, despite the problem of the resonance, we need to know the advantage or the use of resonance that will bring benefits to the HVAC. For example, even though it causes a resonant effect, but this resonant effect can be used for other purpose that we'll discuss later. Okay, and simple HVAC RLC in series. Simple circuit, we have the values and we know the formulas. We should be able to calculate. And in case the questions ask you other values, for example, the inductance or the capacitance or the resistance, you should be able to manipulate the formula, the given formula, so that you should be able to calculate the values that is required. Okay, say this one resistance 0.3. Okay, 0.3 the resistance, and then in case what will happen if we place the two resistance in series or two resistance in parallel. You need to be able to calculate the total resistance values here, so that you don't trap with the questions. Okay, obviously the rest will be the same. Just proceed with the calculations for you to be able to answer the questions. Okay, cascaded transformer. Okay, have a look how we propose this one, how we cascade this one, how we cascade the single stage transformer into three, and at the end we obtain the output of V3. Okay, so this is the way for us to obtain the higher impulse value by using the cascaded transformer. You need to check for the calculation, the circuit construction, how to construct this circuit in order to establish V1, V2, and V3. Okay, I don't read this. And the resonant transformer, last but not least, is that okay, resonant transformer is being used for the benefits. First, to reduce the supply voltage. Since we have the resonant effect, we applied the capacitance that have matched the value to the inductance, and then we will have the resonant. And this resonant can be used, can be applied in order to use for a reduced voltage supply. Okay, this is the benefit that we'll get from the resonant. And the other benefit is that we can ensure a pure 50 hertz power frequency, because the resonant, what resonant do, they try to highlight, try to emphasize on the fundamental frequency. So if we need a pure 50 hertz to deliver at the output or to the load, so we need to ensure that we can actually use a resonant transformer so that the 50 hertz will become obvious. And then other than that, the advantage, and then this the construction design. Okay. We have the variable to varies the conductor, and then we have the transformer, and we have the load. Okay, these are the construction of the resonant transformer. In this case, we place the load capacitance, so that we introduce uh, the resonant effect to this transformer. Okay, okay, this exercise are just similar to what have been explained before. It's soft example. So next we go to the HVDC. HVDC. Okay, we have 4 category. We have half period rectifier circuit. How we generate the HVDC is purely by using the rectifying circuit. We have the HVAC plus the rectifier, then we'll give you the HVDC. Okay, we have the half wave, we have full wave, full period, we have half period, we have a Cockcroft-Walton double circuit, and we have the Cockcroft-Walton multiplier circuit. Okay, all of these 4 circuit or 4 configuration contribute to the generation of HVDC. Okay, we apply the diode here, and then that will give us a load voltage in this way, and then we have the capacitor, smoothing capacitor to smooth out the ripple, so that it's become less distortion. And then we have full period, we add on diode 1 and 2 to the circuit, and then that will give you a full period of rectifier, plus with the damping capacitor, smoothing capacitor, in which this one will smooth out the ripple, and these are the load voltage. The load voltage, as we can see, is better than the half wave. Why? Because we have more cycle here, and the ripple is smaller. It's become smaller. And then we have Cockcroft-Walton double circuit, in which we introduce the diode in this way, and 2 capacitor and 2 diode. In this way, it will produce the voltage at double of the input voltage. Okay, and we also have the multiplier circuit, in which we introduce, okay, the voltage, we cascade the voltage doubler, into 1, 2, 3, and etc. to give us multiplier circuit. So it's just the same to the cascaded transformer for the HVAC. Okay, and then generation of impulse generator. Last for today. We generate impulse generator. Obviously, we don't use the impulse voltage in daily life. We don't use. Consumer don't use. And even consumer or manufacturer don't use the impulse voltage. Then why or how we use? What is the importance of the impulse voltage? As I explained to you before earlier, it need to be for the testing, for the testing purpose, solely for the testing purpose. To test our dielectric strength, to test for the power equipment device, the protection device, so that we need to simulate the impulse. We need to simulate lightning or switching impulse with the impulse generator. Okay, we have 2. The most commonly used, lightning and switching, in which we should be able to differentiate what is lightning, what is switching in terms of their front and rising. Okay, rise time or decay time, 1.2 50 second and 250 2500 second. Okay, should be able. And what are the issues with the impulse generator? Have a look at them. And then we have the single circuit and multiplier circuit. Okay, of course, we cannot for a higher magnitude value of impulse generator, it is more practical for us to cascade the between the transformers, between the single stage. That is what we call as the Mach generator. Instead of to have a very high rating power transformer, will that will cause more in terms of finance, monetary, in terms of the cost. We need also to prepare more on the insulations, clearance, insulator coordinations, and etc. So the best way to achieve this is uh, by using a Mach generator. So this is the circuit of the impulse, how to generate impulse. We have the trigger. We have the trigger. Three important component is the trigger gaps. We have the capacitor and we have the resistor. And combination of these two circuit will we call it as equivalent circuit for this impulse will eventually produce the shape like this one. Okay, these are the shape of the lightning and switching, typical. So be careful of this one. We peak over 50%, so that you should be able to plot very well. Okay, example, and then single stage. Okay, now we go to the multiple stage of impulse generator. They in which they are charged in parallel, concurrently, and they are charged in parallel, and they are triggered by the gaps uh, in series. In that way, we can achieve the several stage to appear at the output. And then the circuit and damping resistor to control the oscillations to provide at the ripple of the voltage waveform. Okay, that's about it of the previous three chapter. A quick summary, a quick recap for those yang dah attempt tengok. Okay lah, dia tahulah. Should be able to recall quickly. Those yang belum, you need to put effort to go through the notes. Okay, and the recorded lecture session. Okay, for the final exam, for the quiz, okay, you have done your quiz 1, which is already done, and then for the test will be in week 12, if I'm not mistaken. Just wait for the official announcement from Dr. Fairuz, I think in week 12. And the chapter cover for the test will be 100% from chapter 3 only, generation of high voltage. Okay, for the test there will be only one questions which equivalent to the one question in the final exam. Okay, one question of 25 marks from chapter 3, generation of high voltage, AC, DC, and impulse. Okay. Okay, as I go through before, take a look at the different type of testing transformer versus power transformer, and the tank type transformer versus insulator type of the transformer. Okay, insulator enclosure type transformer. Okay, we have what are the difference between these two, and then okay, maybe and then you should be able to describe the working concept for the HVAC, working concept of the HVAC, how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing, and then how we produce small scale HVAC testing with its appropriate example. Okay, it's given, and then maybe HVAC RLC circuit. How to calculate the maximum or overshoot voltage value at the resonant during the resonant phenomena. Okay, resonant effect in the HVAC. Working con. Okay, that is for the test. And for the final exam, okay, for the final exam, you need to, okay, the final exam, there will be no questions from chapter 1. Okay, questions one will be from chapter 2, and questions 2 will be from chapter 3. Okay, and the other two chapter is to be announced, the other two questions to be announced by Dr. Fairuz later after he complete his lecture. Okay, uh, so for questions one, for the final exam, there will be 25 marks question from dielectric breakdown, and 25 marks for the questions two from the high voltage generator, ataupun, or in other words, how to generate the high voltage. Okay, I don't go a very specific topic, because this one, all I can assure you, all I can assure you that the answer should be available from the notes. Okay, the answer should be available from the notes. It just a matter, maybe it's not like a very specific point. Maybe from the discussion in the class, the discussion during the lecture, recorded lecture, and the discussion that we discuss throughout the time. Okay, and some of them you should be able to answer it based on your understanding. You don't need to memorize, you don't need to recall, or you don't need to refer to the notes anyway, although all the answers should be available from the notes. Uh, that involve, I would say, maybe 50-50 comprehension, and 50% or more, maybe 50 to 60% on the calculations for questions 1 and 2. So it's about balance. The calculation, the work example is available. It's available for you in the notes. Give a try. Please attempt them at your own time. So please try to recalculate. Try to recalculate the formulation and the tutorial, so that you are quite confident for you to address it in the final exam. And then maybe you are requested to sketch the waveform, for example, the output waveforms, maybe to propose the circuit for the high voltage generation. What is the circuit for the specific output requirement? So have a look at the circuit configurations, how we generate the circuit, how we generate the high voltage, and with the expected output waveforms. Okay, and other than that, it will be like differentiate between two phenomena, between two theories, between two types of things, that kind of thing. And maybe you need to justify or explain any assumption made to perform the calculations. Okay, I think that's about it. I think I have covered almost all, and that summarizes everything. And for the impulse section, I do believe I won't repeat, as I record the notes record the lecture from the section 2, or if I'm not mistaken, even though the image quality is not so good, but obviously you can use your slide to understand, to read the notes, not to refer to the video, and you may only just listen to my explanation and then use your own notes in case the quality is not so good, so I don't repeat that one. Okay, any other questions? Aiman Hidir, anything you like to ask? Aiman Hidir with Johannes, ada tak? Kira tak ada dah. Ada tak?
Yes.
Yes, with Johannes. Do you have any questions or anything that you want me to explain further?
No, doctor.
No.
For now, no.
For now, no. Right? That's fine. Okay. Farisha Diana, ada? Do you have any questions? Farisha Diana.
Yes, doctor. No, I
Ada.
have none. Tak ada
No
soalan.
question juga. Okay, one more. Maybe Farhana. Nur Farhana. Do you have any questions? Okay, dah tak ada.
No, doctor.
No, okay, thank you. Okay, so basically, from this will be our last class for the first 3 chapter, and the next 3 chapter will be covered by Dr. Fairuz. Inshallah, in the next class, Dr. Fairuz will come and join you during this session, okay? During this class meeting. So it means that there will be no longer the class on the Thursday due to your PSM, slot for PSM. So we decided to go for each respective class instead of to meet on the Thursday, because we didn't notice that one is your slot for PSM. So I do believe Dr. Fairuz later will announce for the his approach maybe might be different to what I delivered, maybe the same, I don't know, but just wait and see. Okay, at any time if you have any questions or concern about the assignment project or about the notes for lecture chapter 1, 2 and 3, you may text me, WhatsApp me. You've got my numbers. You can WhatsApp me, and then I will not reply instantly. Apologize for that. Maybe at a later stage. Maybe tomorrow, like the day after. Okay, if I didn't have time to reply at instantaneously. Okay, what I'll do, if you have any question, you can ask. I can create a simple video to explain those and upload if you want, no problem. And if you want me to come into the class at any session, no problem as well. I can come for a short while to explain on any particular topic that you would require extra explanations, or on which topic that you don't understand. Okay. Last, Nabil Ashraf. Ada Nabil? Nabil Ashraf. Okay. Okay, that's about it. You all balik tak kampung ni? Raya?
Balik.
Balik? Boleh balik Ada yang stay? Berapa ramai yang stay? Berapa ramai yang stay?